The topic that we are taking up today is bistables. Bistables means there are two stable states. The stable states that we are talking about could be one high or it can be zero low. Fine. Suppose there is the zero state, the output will continue to be zero as long as there is a trigger which wants to make it one. Once the trigger makes it one, okay, it will stay at one till there is another trigger pulse which makes it go zero. So both 0 and 1 states are stable. That's why it's called as bistables. Fine. Bistables can also be called as flip flops. Understand? So there are three types of bistables. First one is RS bistable. Second one is let's say D bistable. Okay, when we say RS, it is reset set. R means it is reset. S means it is set. D means it can be regarded as data or it can even be called as delay. Fine. The third one is JK bistable, which is improvement on RS bistable. So this is improved version of RS bistable. How will be explained later. So the first one that we want to take up for discussion is RS bistable. RS means I've told you reset set bistable. Understand that? Now, when we say reset, okay, the output would be reset. If we do reset of something, output would be what? Output would be equal to what? It would be 0. If we say set, the output is 1. Understand? So if you are resetting the flip-flop or bistable, the output would be 0. If you are setting, the output of the bistable would be 1. Understand that? So that means when reset is 1, okay, it implies that output is 0. When set is 1, it implies that the output is 1. Fine. This is what the purpose of using RS bistable and input reset and set. Fine. Now, if you see the block diagram of RS bistable, it looks like this. Everybody should understand this. This is block diagram of RS bistable. Fine. It has got two inputs. Let's say one is reset, the other one is set. So this is set and this is reset. And it has two outputs, Q and Q bar. So how Q and Q bar are related? If Q is 1, Q bar is 0. If Q is 0, Q bar is 1. That means they are not of each other, complementary of each other. Okay, or they are invert. So this is invert, not of Q. So this has to be read as Q bar is what we have to see it as. So Q bar is read as Q bar, and this actually is not of Q. Understand that? So it has got two complementary outputs, we can say. What has it got? It has got two complementary outputs and an input which is used to reset the output. That means if R is 1, Q is 0, and if Q is 0, Q bar is 1. And if set is 1, Q is set. That means Q is 1, okay, Q bar is 0. But since there are two inputs, okay, we have to take care of the four combinations. Let's see which are those and how to see them. Okay, so let's see the truth table. So as we have been seeing, there are two inputs, right? Let's say set and reset. Okay, and two outputs, Q and Q bar. Is it okay with you? Now, with two inputs, fine, we will have four combinations of input 0, 0, 0, 1, 1, 0, 1, 1. Fine. Now, for these input combinations, what are supposed to be our outputs is what we are interested in seeing. Fine. Now, if set is 1, it sets the output. If reset is 1, it resets the output. If both set and reset are 0, 0, what? See here, if something is 0, it means don't do. We can see it in that way. If something is 1, if the input is 1, it says that do. 1 you have to read as do that, and 0 don't do that. Okay. Now set is also 0, reset is also 0. That means what is it saying? What is it saying? 0 means don't do. So that yes is 0 means don't set, and R is 0 means don't reset. So this is how one needs to see it logically. Everybody understand? So this particular combination of yes R tells us not to set and not to reset. So we are not setting and we are not resetting also, means these outputs will not change. So Q would be Q, Q bar would be Q bar. Let's see the description of this. Description. That means no change. No change in the output. Is this okay with you? Why there is no change in the output? Because you are not setting. 0 means don't do. So don't set, okay, is what this is. And similarly, don't reset is what it is saying. So there will not be any change. So Q will be Q and Q bar will be Q bar. So we say there is no change in the output if set and reset are 0, 0. Fine. Now, as we read, set is set equal to 0 means don't set, reset equal to 0 means don't reset. Okay. So if you have understood this combination of input, what is this combination of input telling you? Anybody? The second combination of input. Yes is 0, reset is 1. So what is it asking us to do? Can anybody respond to that? When S is 0 and R is 1, what is it asking us to do and what is it asking us not to do?
Don't set, do reset.
Very good. Don't set, do reset. So if you are resetting means what should happen to the output? If you are resetting, the output should become 0. Okay. So if it is 0, this is 1. So if Q is 0, Q bar has to be 1. So that means output is reset, is the description that we have to go. On the similar grounds, if S is 1 and R is 0, it is telling us to set, okay, the output. It is telling us to set the output. Setting the output means making the output Q 1, which means that Q bar would go 0. Understand? Okay. Now, what is this telling you? Anybody? S is also 1, R is also 1. So what would be your output Q for this particular combination of SR? So this is interesting. Can you see what happens if S is 1 as well as R is 1?
No change.
Don't set, don't reset is no change. But can you read this? If S is also 1, reset is also 1, can you read this according to this?
It remains the same.
No. No change and it remains same is the same. You are just telling it in different words. That's it. Anybody? No, don't tell me about the output. Just tell me what is it asking us to do. It is asking us to set as well as reset. Okay. So if we reset, this is what is happening. If we set, this is what is happening. Okay. But here it is asking us to set as well as reset. That means the same Q, we want to make 0 and 1 both at the same time, which is not possible. Everybody understand that point? This Q you are seeing here for this combination of SR, okay, needs to be set and reset at the same time, which is not possible. So we call this as indeterminate. Indeterminate. Indeterminate means what? I don't know what to do. So here in this third combination, what is happening? Output is set. In the last combination, it is indeterminate. We cannot determine. Cannot determine. Why cannot determine? We cannot determine this since Q cannot be set and reset at the same time. At the same time. So this is what you should understand. Is this truth table okay with you? Everybody understand this now? Okay. So what is this SR bistable all about? Okay. So let's see this functionality or this particular function can be realized by using the NOR gates as shown here. Okay. So how does the logic diagram or the circuit diagram looks like? Logic or circuit diagram. Everybody see here now. We can realize this by using two NOR gates. Which gate is this? Can you tell me which gate is this?
Or gate.
OR gate.
Or.
Which gate is this?
NOR gate.
NOR gate. Very good. So we are using, okay, NOR gates to deal with this. Using NOR gates. Fine. So such two NOR gates we need. Such two NOR gates we need to bring the functionality of SR bistable. So this is the output. Fine. So this output of one XOR gate should come to the input of the second XOR gate. the output of first XOR gate has to come to the input of the second XOR gate. Fine. And here, the output of second XOR gate should come as the input to the first XOR gate. Is this understood, everybody? Okay. And since this is a gate, this should have multiple inputs. So this is the second input that these gates will have. So I'll write that for you here. See here, this is one XOR gate. I'm just showing you what I've done there. Fine. So I have two or NOR gates rather. So they are the two outputs. So one of the outputs, one output of one gate will go as the input to the other. Okay. And that is what is happening with this also. Is it okay with you? Then you have another input like this. Fine. So this is how we've written. You can practice that, it will come. Not a problem. For the first time you're seeing this. So this is this is called as cross connection. Fine. Now this is reset, this is set, and where reset is there, there you will have your output Q, and where set is there, there you will have your output Q bar. Everybody understand this point now? Now, suppose one of the inputs of NOR gate is 1, means what would be the output? Suppose, let's take this. Let's just understand the NOR gate first. Understand the NOR gate. Fine. So let's say this is AB and this is output Y. Fine. How the NOR gate acts as? So the four combinations are 0, 0, 0, 1, 1, 0, 1, 1. If both the inputs are 0, 0, what would be the output of NOR gate? Anybody? So you have to OR. That means 0, 0 is 0 or 0 is 0. So not of that is 1. 0 or 1 is 1. Not of that is 0. So 1 or 0 is 1. Not of that is 0. 1 or 1 is again 1. Not of that is 0. So this is what is NOR operation, NOR gate output. Now we have to see if this particular truth table works with this particular circuit diagram. So let's try to check this. Fine. So output is not changing is what is there when SR is 0, 0. Okay, output is not changing when SR is 0, 0. They are saying. Fine. So let's say this. Let Q be equal to 0 and Q bar equal to 1 to begin with. To begin with, let Q be equal to 0 and Q bar be equal to 1. Okay. So let's see case number 1 now. What is case number 1? Case number 1 is when R equal to 0 and S equal to 0. So this is case number 1 and our outputs are 0 and 1, suppose. We have to have some output because for R equal to 0 and S equal to 0, the outputs will not change is what it is saying. Okay, so first is what we are checking now with Q as 0 and Q bar as 1. Okay, what I mean is this. So we have the circuit diagram like this. Fine. So you have outputs and the outputs will come as inputs like this. Fine. So here are your R and 1. R and S. R S, Q with R, and Q bar with S. And what are we saying? This Q is 0, and this, if this Q is 0, Q bar is 1. And what are we doing here? Q is 0, Q bar is 1. Q is 0, Q bar is 1. So this is what is written here. Q is 0, Q bar is 1. That means this Q is 0, Q bar is 1. Okay. And R is 0, S is 0. So that means this R is 0 and this S is 0. This is what we're doing. So what we need to see is, with R and S 0, 0, would Q be still 0 and Q bar still be 1? Because here for SR 0, 0, okay, the output will not change. So that is what my interest is. Will Q stay 0 and Q bar stay 1 when R is 0 and S is 0 is what we need to check for. Understand? Now, Q is 0 here. Okay, so that means the Q0 would come here. Fine. So in this XOR gate, both S and S is 0 and the other input is also 0. That means if 0, 0, what should be the output? Output is 1. So Q bar is 1. And this 1 would become input to the first OR gate. So that means if any of the inputs is 1, if any of the inputs is 1, the output is what? 0. See here, one of the inputs is 1. So obviously the output would be 0. So that means the present output was 0. Here Q, Q, N bar were 0, 0. So we can call them as present outputs. Present output. Fine. If these two are present outputs, okay, how I should mark my, sorry, what is wrong here? Qn bar would be 1 if Qn is 0. If Qn and Qn bar are present inputs, what would be our next output denoted as? Can anybody, just out of curiosity, I'm asking if you can denote that properly. Qn is present state of the output. What would be the next state of output corresponding to this? Anybody?
Qn plus 1.
Very good. So Qn plus 1 would be the next state of Qn. That would also remain same. Okay. Similarly, Qn plus 1 bar would be 1. That means Q remained 0 remained 0 and this 1 remained 1. That means there is no change in the present outputs and the next outputs. So output has not changed. Therefore, output is not changed. Output is not changed when R is 0 and S is 0. Is this understood, everybody? Is this understood? Okay. Now we shall go with the second case. Case 2.
Sir, can you explain it again, please?
You want this to be explained again? Okay, just see
Sir.
here. We are going with the case 1. When we are going with case 1, I just want to see this combination of SR. So this is first combination of SR that I am taking as no change combination. Why? If S is 0 and R is 0, don't set, don't reset. Don't do anything is what it is saying. Don't set, don't reset. So that means it is no change of the output. So we are saying no change of the output, right? So let us assume these outputs to be some value. So that value I was assumed to be 0 and 1. Q is 0, Q bar is 1. Is this understood? This is just an assumption. Because I need to show that this particular output, what I have considered, will not change for R is equal to 0 and S is equal to 0. Okay. Now, R and S are 0, 0, and Q and q bar are 0 ones. Fine. Now this q is 0, right? So this 0 is being given as input to this. So this is being given as input to this. You see this? So this q 0 is coming here. And in this NOR gate, okay, both the inputs are 0, 0. Now, is that understood? So when both the inputs are 0, the output is 1. So this output is 1. It is not changing. Earlier also it was 1. Now also it is 1. Now this output 1, q bar equal to 1, is given as input here because this is being fed back here and it came here. Now R is 0, but the another input is 1. If any one or more than one input is 0, what is the output? Output is 0. So that means earlier q was 0. Now also q is 0. So the earlier this q I am representing as qn to denote the present state. And this is the next state. So present state qn is 0. Next state is also 0. That means there is no change. Is this understood now? Yes?
Yes, sir.
Okay. Now, what would be the second case? Tell me. Second case is when S is 1, S is 0, and R is 1. Let's take this. When S is 0, R is 1. When S is equal to 0 and R equal to 1. So when set is equal to 0 and R equal to 1, what should happen? What should happen here? When S is equal to 0 and R equal to 1, Q should get reset because it is telling us to reset. R is 1, that means we should reset. So Q would get reset, that means it would become 0. Q bar would be 1. Will this be true is what we are checking now. Okay. Now let's take the same diagram. Everybody just see here. We shall take the same diagram. And we shall take it here. Fine. Now, what is R? R is 1. S is 0. Previously, what was Q and Q bar? Previously, Q and Q bar were 0 and 1. Okay. If reset is equal to 1, Q should be 0. So that means again the same state should continue. Let's see what happens. Okay. Now, see here, this Q would come here. So that means this is 0 now. So when both are zeros, Q bar is 1 and this 1 comes here. So when both R and 1 are, so R and this is 1, 1. So Q should be 0. That means when reset is 1, Q is reset. Understand that? Or in other terms, let's say this. Assume Q to be 1, okay, and Q bar to be, let's do this, Q bar to be 0. That means I can change this now. I can change this. Okay, so accordingly, let Q be 1 and Q bar be 0, which means that these two will change now. Okay, see, so Q is equal to 1. So that 1 will come here. That 1 will come here. So what happens if any one of the inputs is 1 for an NOR gate? If any of the one inputs is 1, what happens? Q is 0. If any of the, so Q, this Q bar is 0. So this 0 comes here. What happens? So we should not take the same actually. So let's go with 0 and 1. Let's go with 0 and 1. Then you will understand. Okay. because otherwise they'll not be able to make out. So this is 0 and this is 1. So this is 0. If both are 0 zeros, q bar is 1. And if this is both are 1 1, q is 0. So that means if r is equal to 1 and s equal to 0, okay, the output is reset. So that means that is q would be 0 and q bar 1. Suppose if we do this otherwise, what I mean is, now I'll change the output. So these outputs, let's change and see what happens. So I hope you're following this. Let's say now change, assume q is 1 and q bar is 0. This is what I'm seeing. So q is 1, q bar is 0. So this is 1 now. Okay, this will never happen. This will never happen because what is because q can never be 1. If reset is equal to 1, q should become 0. So this is present state is 1, let's say. Okay, let's see what happens with this. Fine. So when q is, if any of the one inputs is 1, see everybody, if any of the one inputs is 1, what happens to the output? If any of the one inputs is 1, what happens to the output? It is 0. So q would be 0. This is fine. Q would be 0. So that 0 comes here. So 1 and 0 is what? If any state has got this, reset has to be 0. Okay. So this 0 again comes here. So this would become 1. This would become 1. So that means Qn and Qn bar. So this is Qn and Qn bar. Fine. So Qn is 1, Qn bar is 0. But what is Qn plus 1 and Qn plus 1 bar now? Qn, this is 0 and this is 1. So 1 became 0, 0 became 1. So that means the output is reset. Understand that? Here anyways we had considered the reset output. So the same continued. Fine. Here we have taken, we had started with Qn equal to 1 and Qn bar equal to 0. Fine, let me write it properly. This is Qn bar. Fine, this is Qn plus 1 bar. So 1 became 0 because the output has to be reset. Earlier it was 1, let's say. Okay, so it will get reset. Understand that? So this is how the things go. So let's go with case 3. What is case 3, everybody? Case 3, let's move on. So this is what we shall take. This is case 3. Okay, and let's go from here. So what is it? Qn is 0, Qn bar is 1, present state. Okay, so these are all present states. Assume These are all present states. Fine. Now, similarly, we have assumed the present states to be 0 and 1. So, this is 0 and this is 1, and S is equal to 1 and R equal to 0. So, this is the state. So, S is equal to 1 and R equal to 0. Okay. Now, this 0 comes here, or let's say this 1 comes here. What happens if 1 and 0 are there? This has to be 0. That means it is not getting set. What should happen to set? Q should become 1 now. This Q, which is having 0, okay, should become 1 when set is 1. How to see it? So we have to go one round of operation. Fine. So when would be the output of OR gate 1? Output of OR gate would be 1 when both the inputs are zeros. When both the inputs are zeros. Fine. So here Q is 0 and S is 1 here as of now. So when the set is 1 and this is 0, okay, so what would this be if one of the inputs is 1 and any one input is 0? If any one of the inputs is 1, if any one of the inputs is 1, the output is 0. So that means this would become 0. Q bar would become 0. Let me write that this way. So Qn plus 1 bar would be 0. This is Qn bar. So this Qn plus 1 bar is 0 comes here. So both are 0 zeros. When both are 0 0, if this is Qn, okay, Qn plus 1 would be 1 because both are 0 zeros. So that means the output is being set. Here Qn is 0, Qn plus 1 is 1. So that means from 0 it became 1. You need not have to see this. Don't bother about Q bar. Okay, just bother about Q. That is sufficient. So here earlier it was 0, but since set is 1, it became 1. So what is it? Therefore, the output is set when S is equal to 1 and R equal to 0.